And hello, everyone, and welcome to PyLadies Dublin this evening. This one's meeting. I'm Vicky, your co-host. I have Leia and Michael here, who are also helping me out. And we're gonna start off this morning, or this morning. This start off this evening with our with announcements. And then, as with our running order, there's a kind of we've an extra speaker, but so it's a very short talk, just before Olga. So let's start with the announcements. So first of all, I'd like to thank our community partners. So for Coding Grace for providing Zoom, so we can actually broadcast our speakers and and their talks, and of course to Imagi for who gave a talk earlier this year, but they offered us a discount code, Coding Grace 15, so you can visit their store. So Optum is also our sponsor. I forgot to add it. I'll add it in later. I knew there was something missing, but it's in the banner on the Meetup page. So our talks this evening, we have, as I said, we have a few talks. So a very short one by Megan. It'll be about Optum, and then it will follow by Olga talking about text classification using HuggingFace Transformers, and it will be followed by Sahana talking about PySpark 101 tips and tricks. So for anyone who's joining us this evening, do pop your questions into chat. We will have Q&A after each talk, after each talk, and Lay will help field the questions, and we can ask the speakers. But the speakers can also ask you in live chat, so feel free to chat away. After that, for the talks, we do have a live raffle, and I will leave Megan or Olga to let you know what the prizes are. I can only tell you there's like 2 of them. So if you want to participate, we'll ask at the end who wants to participate in the raffle. And if we will use an online name picker, and if you win, I will ask people to email me at dublin@pyladies.com, and I will connect you with Olga from Optum, who will give you details on how to claim your prizes and their physical prizes. So here is the running order. I do have my cup of tea and coffee. I actually have both. So we're all settled down. In the middle of my welcome and announcements. And just before Olga, Megan will be in there, giving a short overview of Optum. So after now I've done the schedule already. So there's just some announcements. Like I am looking for speakers for upcoming PyLadies, September, October, and November. We are working with some folks for October, but it's not confirmed. But if you feel that that you want, if October suits you better, then let us know. We can work something. Be great to have a number of talks that month. But we definitely are looking for people to speak or demo in September. And there's a type form that you submit your details to. And this whole announcements that I'm going through, I will share on the event page on Meetup, and I will send it out to people after those who RSVP'd on Meetup. I will send a message afterwards as well. I kept this here, PyLadies on Dev2, which is a developer's blogging platform. It's a really nice platform, and you can find a lot of great articles on all things tech and geeky. So PyLadies is there, but I also have a personal one as well, which is here, a YK. But we also have other people who have helped or participated in PyLadies before. So we have Chuck, and we also hire ladies. The next PyLadies Dublin is on September 21st, and as I said, we are still looking for speakers. So send in your talk details or drop us an email. Other events is Python related ones would be Python Ireland. They are on Wednesday, September 8th, so they're on the second Wednesday of each month. Find out details via python.ie, check them out on Meetup as well. That's where you have the details. I think their RSVP opens the week of their meetup. And finally, the resources. I decided to keep this because some people might want to find resources if they're starting in Python, or what to do right after you do all the beginners kind of workshops. And if there's any other cool resources that you want to share, let me know and I'll add it to the list, and we can share it with everyone so people can refer to it. So that's all the announcements. And so what I will do is I will go to intermission, bring up an intermission slide while we set up our speakers, and we'll be right back in a few seconds.
Hi everyone, my name is Megan O'Brien and I'm a software engineer at Optum. And I'm also one of the leaders of our internal Women in Tech network. So Optum are the sponsors of this event today. And if you're not familiar with Optum, it is the technology wing of United Health Group, which is the largest health insurance company in the US. And Optum have been in Ireland for about 20 years at the Letterkenny site, and since 2016 in Dublin. So we have a really wide range of teams and roles in Optum, from software engineering, data analytics, pharmacy solutions, and advisory services. So then from the Women in Tech Group perspective, our aim is to increase the number of women applying to roles in Optum, so that then we can increase the percentage of women working in tech roles, and that leads to us having a bigger and better and stronger Women in Tech Group that we can do more with. So we're doing a lot of hiring at the moment. There's about 75 open job roles across Ireland, Optum Ireland at the moment. And on my own team, we're actually hiring software engineers, data scientists, machine learning engineers at all levels, as well as directors of engineering. And we also have a career fair coming up on the 25th of August, which would be a good place to learn about Optum. So I can post all of the links to that career fair and the open job roles and things like that. And if you're interested, please feel free to reach out to me on LinkedIn. I can help in any way I can. And if you know anyone who'd be interested in any of these job roles, we'd appreciate if you could pass them on and just spread the word in the women in tech community. So thanks, that's all from me, and I'm really looking forward to our brilliant Optum speakers today.
Thank you. We'll be back with Olga, so see you in a few secs.
Hello, everybody. I would like to introduce myself. My name is Olga Minguett. I'm a data scientist and I work with Optum. I'm also a master's in artificial intelligence student at the University of Limerick. And before I continue, before we started, I wanted to thank Becky, Lay, Michael, and of course PyLadies for partnering with Optum once again for this event. So thank you very much for having us today. So today I'm going to talk about transformers, but not this transformer, this one either, but this one, HuggingFace Transformers. And we're going to do some text classification using this library, and this presentation will be divided in two sections. The first one, some key terms, definitions, how the library is set up, and how the different models are used. That is about theory. And the second one is just practice. We will take a look to some code using Google Colab to check the different tasks that can be performed using transformers. And then we will move towards doing some fine-tuning a text classification model using BERT. I will like to say that I am not an expert in using this library. I'm a newbie. I consider that I'm in a newbie stage, but I would like to share all of the insights and findings that I have encountered using this incredible library for NLP. So let's start with some theory and some key terms that I would like to define before we start, which are NLP, NLU, and NLG. And NLP is the ability, or natural language processing, is the ability of a computer to process and understand human language, and it could be in a spoken or written form. NLU and NLG are two subsets of NLP. So NLU refers to the enablement of a computer to interpret human language using syntactic or semantic analysis. What do we mean by that? Is basically the syntax refers to the grammatical structure of a sentence, while the semantics alludes to the intended meaning of it. NLG, or natural language generation, is basically generating written or spoken human language for structured data generated by the system to respond to a task or to an action. And a bit of a difference between NLU and NLP is like while NLU focuses on computer reading comprehension, NLG, on the other hand, enables the computer to write. And a couple of examples of this, you can see some customer feedback analysis, automatic translation, email classification, same when we see in our Gmail or Outlook, the different type of inboxes that we can set up there, or even text summarization. But what is HuggingFace Transformers? What Transformers is basically a library that contains state-of-the-art pre-trained models for NLP tasks and perform over text, and they could be feature extraction, fill-in mask, name entity recognition, question answering, could be a yes or no or more complex one, sentiment analysis, if you love or hate something, summarization of long texts, text generation, and translation in various languages. Transformers is just basically helps you creating APIs to download and use all of those pre-trained models. It could be on a given text, or if you want to fine-tune them, you can bring along your own data set. Each module is a defined architecture, so they're fully standalone. They can be tailored to any of the experiments that you're running using the library. And they also have 3 other main integrations with 3 different frameworks or libraries. In this case, is JAX, PyTorch, and TensorFlow. And in case you're not aware of these libraries frameworks, JAX is basically Python plus NumPy library for high-performance ML when you're using CPU, GPUs, or TPUs. PyTorch is the Python version of the Torch library, which is an open source machine learning library that specializes in tensor computation and dynamic neural networks. And last but not least, we have TensorFlow, a very well-known framework, which is an open source software library for ML that is used for data flow and differentiable programming. So a bit of an overview of the pre-trained models that are available here. So we have a GPT, which is generative pre-trained transformers. which is also called our autoregressive model, because it will try to predict a future behavior based on past behavior. We have a BERT model, which is also called autoencoded transformer model, which is a bidirectional encoder representation for transformers, BERT. And they're autoencoding because it's simply the reconstruction of an input from some text given. And finally, we have BART or T5, which are a sequence-to-sequence model, which is basically a model that is capable, after ingesting a sequence of particular kind, it could output another sequence of another kind. The transformer models are basically language models that can be two different types. The first one are general trained models on large amounts of raw data. This is done in a self-supervised fashion, and this is done is just trying to automatically compute the inputs of the model, and is done with without human annotated labels. And in the case that we want to fine-tune one of those models, the other model will be a specific trained models while we're doing transfer learning, which is basically after doing the fine-tuning, so in a supervised fashion with all of the human annotated labels, so that the labels that we are giving it to the model. So as I mentioned before, and in the past slide, we have, for instance, like we have the decoder models, which are the GPT-2. We could do some tasks like the causal language modeling. And for instance, when you are typing in your email, and while you're typing, it's prompting you with the intended next possible word. That is basically what is causal language modeling, and this refers to natural language generation type of task. For encoders like BERT, we have tasks like sequence classification, question answering, and masking language modeling. For instance, question answering, when we give certain input to the model, and then we use the model to ask questions about the text that it was given. For in this case, it will be natural language understanding type of task. And for last, we have the sequence-to-sequence models, as I mentioned. We have BART of T5, where we can do some type of translation and summarization type of tasks that can be NLU or NLG, as translation is NLU and summarization is NLG. And that is basically represented here. If you notice, like this will be the type of encoder, the encoder models. It will be bidirectional if self-attention type of models. And then the decoders will be one direction, autoregressive, and mask self-attention. And when we are referring to a sequence-to-sequence, is the combination of both of them. So we go here. Some prerequisites, so this is how I call it, which is basically information that you need to have before you start your project, and that you need to know. For instance, the type of task that you want to perform. Oh, sorry. I guess we have 22 different type of tasks, and that is basically the use case that you would like to perform, or the different types of model configuration. Then we have the model. You need to define which type of model it can be tailored to the task that you want to achieve, that you want to perform. And they have over 13,000 different types of models. The library, as I mentioned before, I don't know if you remember, we have JAX, PyTorch, TensorFlow. That's not the only libraries that they have available. They also have other 22 libraries that you can use to optimize your task. And finally, we have over 1,100 data sets, which is like the different collections of data that they have, that even you can bring your own data set or fine-tune the models over data sets that they have available. Something that you should know is, like, one of the most basic objects that you will use in transformers is basically the library, the object pipeline, which it will connect the model with all of the necessary pre-processing and post-processing steps that it will allow you from the input that you're giving to to the library, get an intelligible result or answer from the model. So if you happen to go to their website, you also will see how this is how the data set looks like and why this is important. When you are working over tasks, for instance, I'm on the Spanish speakers, and if I want to work over a task, for instance, a question answering task, and it will be better to use a data set that is in Spanish. Or if you want to do it in English, obviously it will be an English, or even it's a multilingual. You can select the ones that they're referring specifically to that language in order to pick the right data set if you want to use one of the ones that they have available. And for the model, yeah, after you select your task that you can see here at the top left, and then depending on the type of task that you would like to perform, you have different types of models, and then it gets filtered depending on the libraries that you want to use and depending on the data sets that you want to use. So yeah, so let's move along to Google Colab. Cool. So what do we have here is just basically I'm using Google Colab, and the reason behind that is that you will need to have PyTorch JAX pre-installed on your environment. So I'm taking the advantage of using Google Colab to have them installed there, and just don't get any of the resources probably coming from my own computer. And so of course you have to install transformers and just to do some importing of the packages, importing also pretty print, just to get a better understanding of the results coming from every model. If you want to use, for instance, some sequence classification, which is sentiment analysis, text classification, and you say, I hate you, and you would kind of like get the label from it and the score of it, it says that it's a negative sentiment, and it score over 99% over the I hate you that we give as an input. Or I love you, it gives a positive label and almost predict like 99.99% accuracy. And if we go, for instance, to extractive question answering, which is basically this pipeline, it's just for question answering, we get a bit of context, which is basically text that the model can use to answer the questions, and then we give the questions and use the context that we gave above, and it will say the question was like, what is this extractive question answering? The task of extracting an answer from a given from a text given a question. It will give you a score, and from the range where you can find that answer, which starts at 34 and finishes at 95. The other question will be, what is a good example of a question answering data set? In this case, the answer is squad data set, and the score is 51, and it tells you from which token to which token you can get that answer from. From mask language modeling, for instance, if we say HuggingFace is creating a blank that the community uses to solve NLP tasks, it will try to find that particular word. In this case, for instance, we have HuggingFace is creating a tool, or is creating a framework, or a library, a database, a prototype, and it will give it as well as a score, or to also how the sequence will look like when including that particular word. For text generation, I found that this is one of the ones that I like the most. It's just you give it an input as like, as far as I'm concerned, I will the length of it, and it will start creating text from it. So it says, as far as I'm concerned, I will be the first to admit that I am not a fan of the idea of a free market, and I start creating a text that it will be a max length of 50 words. For name entity recognition, we have a sequence that says like PyLadies' mission is to promote, educate, and advance the diversity Python community. PyLadies Dublin also aims to provide a friendly support network for women and bridge to the larger Python world. What we're doing here is we are trying to get some entities, recognize some entities from the input text. In this case, it could find names, it could find organizations, location, and as you see, it started to define PyLadies as an organization. So you see the P, PyLadies all over all of the words, and define all of them as an organization. And when it hits Dublin, it comes back with Dublin as a location, giving us 64 as a score. Moving to summarization, what we'll do is just given an input as a text, and it will summarize it. You just have to give just basically these two arguments, of course, including the article, the max length how many words you want to summarize all of that text, and the minimum length. And from all of these, basically says that the most beautiful places in the world is a list of natural scenery on Earth, beaches, tropical island resorts, national parks, and national. It just finishes there, thinking it needs to increase the max length to have a better meaning at the end. And finally, we have the translator, which is basically we can do translation from English to Dutch to German. And PyLadies' focus is to help more women become active participants and leaders in the Python open source community, given a max length of 40. And it translated here. I don't speak German, but I found very interesting to see how that could be translated to German. And finally, I know that all we came today just to talk about text classification, and I will go, in the interest of time, I will go a bit quick around these pipelines that is set up here. Yeah, so basically this is a bit of an interpretation of the code that I learned a lot from this notebook that I found online, and I think everybody will understand how's the structure to fine-tune a model better from an expert than from a newbie. But I will go through it and I'll explain you a bit about it. So it's basically we are installing transformers here. We do a bit of data exploration. The data set that is used here is the Google Play app reviews data set. And if you see here how the data looks like, the username, user image, and some content, review creation, review created version, some dates, and how big the data set is. And then if you notice, we have reviews that go from 1 to 5, and the imbalances in this data set is huge. So it's kind of like we are trying to avoid issues of not prediction. In this case, it would be classification. But for instance, we kind of do a review of the sentiment that it can be performed, that it can be classified here. So we change 1 to 2 to negative, 3 to neutral, and positive, it would be 4 to 5. And then if we continue, we do some data pre-processing. In this case, we're using the BERT model, and we need to do some tokenization of this. And also HuggingFace has its own library for doing all of this process called Tokenizer, and that's basically what we're using here. And BERT needs a lot of pre-processing before ingesting into the model. So we need to pass a constant length of sentences or data every time that we pass it through the model. Some creating path tokens and real tokens that they're going to use for the attention masks. So then let me show you here. This is kind of like how the tokenizer works. This is just an example, as it will give a token ID to every word in the model. We have some tokens like for to end every sentence to the words that we would like to classify over, or some padding. Apologies for the scrolling down here. As I mentioned before, we need to give an input of the same length of tokens. And as you notice, we say that kind of like 140 or 130 here, we can do the cut, but just to make sure, we just like extend the length a bit to 160, the max length. We just do the split of the data between train, test, and validation. And then we start basically the classification. And this will look like, it's a bit convoluted, as it's basically, we're doing the fine tuning of a model, and we're using a torch in this case. So it's kind of like a mix of the usage of torch with Python in this case, and creating all of the structure for the model. And we start training. In this case, it will be a max of 10 epochs. I want to show you here. You have the 10 epochs, how it perform. Blue is a training data set, and yellow is the validation one. And the validation, it did like a bit of 85, and you'll see it here when we do evaluation over it, which it gave us an 88. And yeah, so then we can just use different types of metrics, like a classification report or a confusion matrix, to determine like the true sentiment and how this model perform against the predicted sentiment. And at the end, where we just basically, when we use the test data set, even though it performed like 88%, it is kind of classifying everything as neutral, which is like a bit of positive here. And at the end, we just can use the pre-trained model to do some prediction over raw text. And yeah, I know, apologies, this looks like a bit of too much information all at once, but this is kind of like the pipeline or structure to go when you want to do some text classification, sentiment analysis using BERT, and in particular when using the HuggingFace Transformers library. So this is all what I have today. Thank you very much. If you have any questions, just you can pop it on the chat, or yeah.
Yeah, thanks, Olga. So I was just asking if there's any questions. So hold on. Hey, Michael, can you spotlight me? Please. Thank you. Oh, there you go. There I am, half my face. So any questions? There haven't been any questions so far, but thank you for your talk. That was a lot of information. Is there some anything that you can actually just send over to me to share with those who...
I have like also HuggingFace, it had its own course to explain a bit of the architecture, how transformers work, the importance of transfer learning, why are we doing transfer learning, and why they created this huge NLP library. So I will share all of those resources that I have, and also all of the code that can be found online, but I will just add some links and you can share with everybody.
Awesome. So yeah, that was the question. Can you post a link to the notebook?
Yeah, I will.
There's a lot of information. So thank you. So so would you want to announce the prizes, or do you want to leave it as a surprise, or will we do it one at a time?
Let's do it now. We will like to raffle a smart speaker, a Google Assistant, and also a Google Chromecast. So yeah, so I hope you are as excited as I am with those prizes.
Yeah, we will get the people to put in their names in the hat, or well, in the chat, actually, not the hat. And we will pick a name. So what I'll do now is I'm going to put on intermission screen, and we will get Sahana all set up. So we'll be right back in a sec. Thank you again, Olga.
Good evening, everyone. I'm Sahana Hegde. Today I'm here to talk about PySpark tips and tricks. So I've chosen this topic today based on my past interactions with other data scientists who have mostly said that they use Python or R to solve challenges in big data. While that may not be a bad idea at all, but I wanted to take this opportunity today to show a glimpse of PySpark, which not only does what the predecessors do, but also does it better. Before I dive further into this, I would like to introduce myself. Yeah, so as you can all see, my name spelled out here. Most people in Ireland confuse Hegde to be hedge, and it's just really funny to think of myself as a wall of grass. So yeah, so I come from a place called Mangalore, which is in the southern part of India. I completed my Bachelor of Engineering in Computer Science, and I worked for a couple of companies as an order management system developer in retail domain. I enjoyed my work in India, but I was not very passionate in what I was doing. That's when I started analyzing my strengths and weaknesses. What I understood from my experience at school was that I was a good student in maths, and I felt I need to pursue my career in a domain that would have mathematics. So after doing some research, I enrolled myself into UCD's Computer Science Negotiated Learning Master's Program, and I flew to Ireland in 2017. Once I completed my master's, I worked briefly as an intern with SAP before joining Optum as a graduate data scientist. I've been with Optum for nearly 3 years now, thoroughly enjoying my work while I continue to follow my off-work hobbies. Well, I got married last year just before COVID, and yes, I can say that I had a pre-COVID wedding. So to kick things off, let's start with Spark's architecture, which will hopefully be a good fundamental overview. So Apache Spark is an open source distributed processing system used for big data processing. It utilizes in-memory caching and optimized query execution for fast queries against data of any size. In a simple term, Spark is a fast general engine for large-scale data processing. So when Spark is initiated, an independent process is spun up and is coordinated by Spark context or a Spark session. So cluster manager that links Spark context to worker nodes then assigns work to the workers. So 2 workers are shown here in the diagram, but in reality, there could be n workers. So task executes a unit of work to the dataset, and it outputs a new partition dataset. As multiple operations are executed to the data, they take advantage from in-memory computation powered by caching data across these operations. So depending on the operation, aggregation results are either sent back to the driver or can be saved onto the disk. So in backend, a directed acyclic graph or a DAG is generated when we submit code to the Spark console. When action is triggered, so when I say action, it can be aggregation or saving data. So Spark submits the graph to the DAG scheduler. The scheduler then divides this DAG to different stages. So every stage can contain several partitions of data, and DAG scheduler groups all these bundles of individual operator graphs together. So there are several properties that I can think are possibly noteworthy, but it is important to know that there are other properties as well that are worth exploring. So Spark is immutable. That means a unit of data cannot be reversed after a transformation, which can be important to achieve consistency in computations. So say there is a work failure during data transformation, the data can be recovered by reapplying the same computation on that partition in the lineage. Spark also does lazy evaluation, which means all the computations in Spark are not done right away. Instead, they are computed only when an action is triggered. So when it comes to data, processing tasks are optimized by placing the execution code close to the process data. So also Spark processes only data that is required using conditions or filtering conditions. That's why it has the property of predicate pushdown. So Catalyst Optimizer is a very important property of Spark. It's Spark's SQL's optimization engine, which can help developer to optimize the queries built on top of both data frame and dataset. So Catalyst is one of the Spark SQL modular library that is supported by both rule-based and cost-based optimization. So rule-based optimization proposes the set of rules to find the number of ways in which a query can be executed, and cost-based optimization is a step to compute cost for all these rule-based queries and helps the engine to find the best suited approach to execute the SQL query. So now you might be wondering where PySpark sits in the ecosystem. So PySpark can be conceived as a Python-based wrapper on top of Scala API. So PySpark communicates with Spark's Scala-based API through the Py4j library. This library allows Python to interact with Java virtual machine code. So now we will look at the ways in which we can interact with data in PySpark via RDD, datasets, and our favorite data frames. So however, we'll be focusing on data frames in next sections. So RDD is a resilient distributed data sets. They are immutable distributed collection of elements, and they're best suited for semi and unstructured data. They can be used to access data elements in ease and control, but they're only used for low-level transformation. They come with their own challenges, so that they are optimizations and performance gains are absent, but they can be converted to data frames by defining schema. So dataset is a distributed collection of data. They have benefits of RDD, but they're available only in Java and Scala. But due to Python's dynamic nature, many of these benefits of dataset APIs are available already. So data frame is dataset ordered into columns. So they hold data in column and row format like a table. We can pursue the columns to be the variables and rows to be the associated data points. So they're conceptually equivalent to a table in relational database or a data frame in R or Python. But they have richer optimization techniques. They're available in Java, Scala, Python, and R. So from now on, I'll be showing some coding snippets that can help you, start working with PySpark. So yeah, after starting or after setting up connection to Spark, we initiate the PySpark session. So as we recall, Spark session is an entry point, and it connects your PySpark code to the Spark cluster. So in the first coding snippet here, I initiate the PySpark session, and I also define the application name. So I'm using our very favorite Titanic dataset here, just to show how it works. But here I'm reading the file, the CSV file, and we can even specify some more options like separator, schema, etc. We can even read files from Hive tables, and they're worth exploring. We should also remember that Spark only maps relationship upon reading a data source, and it will not bring any data into memory. It will bring data into memory only when an action is triggered. So the last coding snippet here is a very handy function, or it's a very handy function when it comes to any kind of exploratory data analysis. So we use a filter function on the data frame and pass multiple conditions based on our condition. And we search for a null string, and then we look for no value or nothing. And lastly, we look for not a number value. So some more data manipulations. The first one here, this is used to check one-way frequencies. where we check the number of times cabin has appeared, and the result is then counted, or the appearance. We do the counting of the appearances of cabin, and this is sorted in descending order. So here we can see that we can couple multiple functions together in a single line of code in PySpark, and it just does it in a very easy way. So so the result of this coding snippet looks like this. We group the cabin and we count the occurrences of cabin, and then it's ordered in descending order. So the next coding snippet here is to sort and filter, where we subset and create a temporary data frame to eliminate any missing values. We then use this data frame to count the occurrences with cabins that are repeated more than 3 times. And then we sort them in descending order. And yeah, the result of this coding snippet looks like this, where we group cabins and then count the number of occurrences that are greater than 3. So the last 2 coding snippets here, this can be a very handy function as well, to check the distinct number of occurrences using count distinct function. And yeah, the last one is for distinct occurrences using distinct function. So yeah, here I'm showing some filtering techniques using string values. The first one is using the like function of SQL and specifying a pattern. So the next one would be to filter out some names ending with string s. And here again, I'm using the like function, which is a SQL function. The next one would be using rlike function, which is a regular expression function, and which will to find any word character, which means alphanumeric characters. So this can also be done using a function called contains, where we specify the pattern. And yeah, and the last function here can be a very handy function again, when we have thousands of columns and we want to subset the columns by a particular prefix or a suffix. This can be done using this call regex function. So here we use some aggregate function, which is used to calculate mean age. And then we use the collect function here to retrieve array of row type. So mean age will have the value mean age of all the age columns. And we then create a new column called mean age. And then we make use of this lit function, which is a way to interact with column literals. And it is very useful when we want to create a new column and then assign value directly. So in this way, we are creating a new column here, and then we are assigning all the row values with the mean age. The next one would be to use the when condition to create a new variable. So here we are creating a new column called budget ticket, and which specifies if it is a budget ticket by using when function to specify the threshold. So we are specifying the threshold for this particular column called fare. So whenever fare has less than 25, a value called less will be populated in this column. And if it is greater than 25, then it will have value high. So this is a very important function as well, which solves a lot of our problems when we do any kind of exploratory data analysis. Window function is again a prominent function which facilitates the performance of calculations across a set of rows in reference to an existing row. These are extremely useful when you want to calculate analytical functions pertaining to a time. So a lot of feature engineering revolves around windowing functions. So when you're using a windowing function, you will have to specify 3 important components. The first one would be partition, the second one would be order, and the third one would be frame. So in this coding snippet here, first we select the subset of columns that we would want to use for a partition. Then we define our partition, where we specify the row that we want it to be included in the same partition. And then we would specify the order of if we want ascending or descending order inside the partition, we specify that here. And then we call our window function called rank, which is used to provide a rank to the result within a window partition. And finally, we specify how many rows we want to include above or below the current row. So here I'm specifying rank. I want rank equals 3, and also I'm looking for a p class 3 values. So this is the output of the windowing function. So there are some other useful functions which can be used in our day-to-day work. And one of those functions are collect list, which gathers all occurrences as a list. So this is used to aggregate the values into an array type. So here you can see that we are filtering firstly, we are filtering the columns with, or filtering the rows with fair greater than 50. And then we group by fair, and then we collect all the cabins that comes in that partition. So this is how the output looks like. So random sampling with or without replacement. As we all know, simple random sampling with replacement is when once an observation is randomly selected from the population, it is put back into the data set before a second observation is made. So in other words, selection of one observation will not affect the outcome of the other observations. And simple random sampling without replacement is once an observation is randomly selected from the population, it is not put back into the data set before a second observation is made. So, so this is the function that is used to do the random sampling. And yeah, you can see that the first argument here is with replacement. It can be true if it is with replacement or false. And then the fraction, which indicates the proportion of population you would like to have in a sample, and seed, which guarantees the same result when run the snippet every single time. So there are some other functions as well. So cache is a very important function, which so when the data is cached, Spark stores the partition in the JVM memory of each node and reuse them in upcoming actions. So cache in turn uses the persist method, but the storage level will be memory only. And we can specify other storage levels in persist function. And yeah, they're worth exploring. You can explore different storage levels that you can use in persist functions. So yeah, these snippets could be something to keep in your pocket when you get started. And yeah, thank you so much for giving me this opportunity today to present some of the fundamentals. And yeah, happy to open the floor for any questions.
Thank you so much, Sahana, for your talk. Let's see if there's any questions from folks. It looks like there hasn't been any. But I suppose one thing is, would you be able to kind of share your slides with me so so I can share with the folks afterwards as well?
Yeah.
I'll put the link up. I think people have been asking about Olga's notebook, and so what I'll do is I will post them in a message to everyone afterwards, as well as put them on a meetup. Probably handy if I'll put them in the announcements as well. Sorry, that's half my head again. Sorry, that's what happens when I don't see myself on screen. Thank you, Michael, for spotlighting me. So yeah, so while we wait for, I think we do have a question. What would be the, so this is from Vikas. What would be the cons of using PySpark in your experience? Yeah, so what would be the cons? So yeah, the downsides of using PySpark from your experience.
Do I have to type the answer there? Or
no, you just answer here. Captured on video.
Yeah, so in my experience, I've not found any such big cons. To be honest, I like using PySpark because I deal with the big data in my work. So I find it very handy to use PySpark. So I've not, to be honest, I've not come across any kind of cons in my experience, but there could be.
All right. There's a question from Molly. How expensive is random sampling?
Yeah, so in terms of expensive, I can actually do some research maybe and get back.
Yeah,
I'm not very sure because I have not made use of random sampling at all, a lot, and just made use of it sometime. Right. But it worked really well for me, and so I don't know the exact,
that's all right. Yeah, involved. So you have an answer. I can add it to the, the announcement slides I had at the beginning. So if there's any questions like that, you can just email to me, and I'll update that that slide that page I was using earlier on in the announcements. There's another one from Molly again. What are the factors the random sampling cost depends on?
Yeah, the factors can be the arguments that when we specify this, the proportion, or I think those are the factors that can be very important when it comes to cost. But I can actually get back to you in terms of cost and how expensive it is, so that will be easy for you to understand.
Right, and I think. Now, I suppose time is ticking. So what we'll do is I'm going to put everyone back on again. I know it doesn't really make so I'll close off. So if remove spotlight for myself, I remove spotlight. So if the speakers like to put on the videos, so what we'll do now is thank you again to all our speakers this evening. And we have a couple of minutes to go, so let's get this raffle going. We have, what we do is, for people who haven't been to one of our live draws before, if you're interested in participating in a raffle, say yes, and Lay will will copy your names, and we will add it to a name picker, and I will share my screen on that name picker, and we will pick 2 names. So I will let Olga name the prize, and we'll pick a name. So we'll just wait for everyone to say if they're interested. So it's an opt-in from you right now. If you're interested in participating in the raffle, just type the word yes, and Lay will copy the names for me so I can add it to the name list. So I'll give you a few seconds, or a minute or something. If not, then we still have 2 prizes to give away. Or are people just too nice and just come here just slowly for it? Yeah, we have 1. That's an easy pick. If no one goes, you win the prize straight away. Cool. I'll make sure that Lay picks, because it might scroll up. So Lay, at the moment there's 3 names, is it?
Yeah.
I'll give it another okay. I'll give people another 30. I don't know, it might be unfair. I'll give them another 30 seconds. Roughly what I think 30 seconds is, but people be aware that I have drank a couple of cups of coffee and a cup of strong tea, so time for me might be in a very different space for me right now. I'll wait a little bit. So I know we're hitting 7:30, so I'll just wait another 10 seconds. So Lay, as far as I see, it's 1, 2, 3, 4. We have 5 people. I will copy their names. So
yeah, I have all the 5 people.
Cool. The last chance before I get a copy of all the names. And I'll share my screen when I'm ready, when I have the names.
Oh, 1 more.
Right. Good luck, everyone. Just give me a sec. I will share the screen. I just need to get the names first. Okay, a sec. All right, so I'm sharing my screen now.
Name?
What?
I just sent it to you.
All right. Just 1 more, is it?
Yeah, I have all the 6 there.
Okay, cool. So,
have you got it?
Yes, I have got it, and I will share my screen now, and I will share my screen. Let me see. I have far too many. Share my screen. Can people see this?
Yes.
Okay, so we have 6 people to pick a name, and I'm using Ninja Picker Ninja, Picker Ninja. last month we used a wheel, so I'd like to change it up a bit. So I will have Olga announce the first prize to be raffled off, and I will click on the thing to pick a name, I suppose.
Cool. So let's start with the Chromecast.
Okay, good luck. Go. Ooh. So Vika's Prasanna, congratulations. So you won a Chromecast, was it? And what I will need you to do is send an email to dublin@PyLadies.com, and I will connect you to Olga to claim the prize. I'm going to remove the name from the list so you don't win 2 prizes. Okay, the other one is, I'll let Olga announce it.
Yeah, it's the Google Smart Speaker, the Google Assistant.
Okay, good luck to the... Oh. Greg Buckley. Well, congratulations. And yes, same thing. Email dublin@pyladies.com. I will type that in the chat just so you have it. Email Dublin. Sorry, I have a very mechanical keyboard, so that's why it's very clickety-clack right now. PyLadies.com to all winners. So, okay. So congratulations again, and thank you, Olga, for that. And thank you to Sahana and Megan for speaking as well. And thank you to, I'm going to unshare this. Where's the unshare? I want to thank everyone who spoke. I would like to thank everyone who participated this and joined us this evening in the live stream. To, again, Michael and Leigh for helping me out and co-hosting every month. And and congratulations again to the 2 winners. So I hope to see everyone again, including folks from Optum. You're welcome to come and talk. You're doing a lot of cool stuff and talk about lots of things that I don't understand about because I'm not a data person. So it's great to hear about it's great to hear about things that I don't understand. So that's great. And do you have any last words from any of the speakers? No?
From my side, just to say thank you for coming along tonight, and thank you, PyLadies, for having us today.
Yeah. And yes, I would finally like to thank as well Optum, who's our first speakers and also prizes, and to Coding Grace for the Zoom license for us to be able to do this call, and to Imagi who are used to be known as Imagilabs as our community partner. So I will say thank you again and good evening, everyone. Have a great rest of the evening, and we will see you next month. And goodbye.
See ya. Bye-bye.